Hello, my name is Michelle Hobbs, and I will be taking the final exam. Excuse my voice because I am sick. So that's fun. Okay, let's go ahead and share. Oops. All right. Oh, goodness. Okay. Question one, I affirm that I will not give or receive any unauthorized help, sorry, on this exam and that all the work will be my own. I pledge not to share or discuss any of the questions or contents using any websites or apps. I pledge. Sorry, I cannot breathe well at all. The principal at a local elementary school was interested to know if students who attend preschool have higher scores on their kindergarten reading tests. To study this, the principal took a random sample of kindergarten students at his school and asked them if they attended preschool. He then found their reading test score. The principal found that the group of students who had attended preschool scored higher on the reading tests. Was this an observational study or an experiment? Sorry, I will be looking at my notes. Okay, so I think this one is an observational study. Um, because the researchers observe and collect the data without manipulating any variables or assigning participants to different groups. Oh, sorry, my ears are clogged now. Okay. Hmm. So, observational study since no treatment was administered to the students. Observational study since the students were randomly chosen. So, oh, excuse me. So yeah, so the principal simply gathered data on whether the students attended preschool and their reading scores without um, I'm gonna say since no treatment was administered to the students um because in an observational study, the researchers observe and collect the data without manipulating the variables. So there was no treatment done on the variables, which are the students. So I will go with that. Okay, question three. A doctor has invented a relaxation method that he thinks will relieve anxiety and help students score higher on exams. He wants to test the method on a group of statistics students to see if it improves their scores on the final exam. All of the students have volunteered to participate. What is the response variable for the experiment? Um, I think Let's see. Whether students use the relaxation method or not, students score on the statistics final exam, students' overall GPA, whether students liked the relaxation method. The relaxation method affects the variable here, so the response variable is going to be the exam scores of the students. So students score whether the student, yeah, so it's going to be that one. Oh gosh, I sound horrible. A marketing research company was asked to determine how much money teenagers spend on smartphone apps each year. The company randomly selected 80 malls located around the country. A field research, excuse me. A field researcher stood in a central location in the mall and asked passerbys who appeared to be the appropriate age to fill out a questionnaire. A total of 2,050 questionnaires were completed by teenagers. On the basis of this survey, this research company reported that the average teenager in this country spends 155 each year on smartphone apps. In the study described above, which of the following um which of the following is the sample? The randomly selected malls, teenagers that complete the survey, teenagers in the country, field researcher who is giving out the surveys. Um, goodness. I think, okay, so the sample is gonna be completed by teenagers. I think it is the teenagers. The sample is the teenagers that completed the survey for sure. A researcher conducted a study to determine if aspirin reduces the chance of a heart attack. He randomly assigned 250 patients to take aspirin every day and 250 patients to take a placebo every day. After a certain length of time, he reported the percentage of heart attacks for the patients who took aspirin every day and for those who did not take aspirin every day. What is the most important reason for the researcher to randomly assign patients to one of the two groups? Hmm. So that the results of the study will generalize so that there is an equal number of people in both groups for the experiment, so that the groups are similar or have no real difference prior to the treatment, so that the equal amounts of aspirin and placebo would be used during the experiment. So the most important reason for randomly assigning patients, I think, is so I think it's so the groups are similar or have no real difference prior to the treatment because like it helps ensure that on average the two groups, the aspirin and the placebo are similar in terms of the factors that might influence the likelihood of the heart attack. Um, yeah, I think that's good. Or no real difference, yeah, prior to the treatment. Okay. The New York Knicks are a team in the National Basketball Association. The histogram below shows how many points the New York Knicks scored in their 82 games of the 2015 to 2016 season. And how many games did the Knicks score over 110 points? Um, and how many games did they score over 110 points? That would be, let's see. And how many games did the Knicks score? So let's see. Here's all the points. Here's 110. Over 110 points. So 110 is right here. So you're gonna have five, and then four, and then two, and then one frequency. So well, you've got 110 here, and you have everything above 110. So how many games did they score over 110? You're going to add up five, and then four, and then two, and then one, and that's going to be 12. Okay, so let's see. Which histogram most likely represents data with a mean that is less than the median? Skewed to the left, skewed to the right, bell-shaped. Hmm, bell-shaped. I feel like it would be in my notes. It's saying a histogram skewed to the left, I think, most likely would represent data with a mean that is less than the median. Because in a skewed left distribution, the majority of the data points cluster towards the higher values. Let's see. Uh, so yeah, I'm gonna go with B for a skewed to the left. All right, let's see here. Stephen wants to investigate differences in the spending habits of males and females. He studied a random sample of college students. He then compared the amount of money that males and females spent each week on reading materials. Stephen generated the following plots to display what he found. So it looks like males equal 188. Females are equaling 94. Which group will most likely have a higher standard deviation and why? The females will most likely have a higher standard deviation because the median of the data is lower than that for the males. The females will most likely have a higher standard deviation because this set of data is less spread out than that of males. The males will most likely have a higher standard deviation because this set of data is more spread out than that of the females. The males will most likely have a higher standard deviation because the median of the data is higher than that for females. Uh, I think, hmm. Oh. So I think it's going to be standard deviation because I think it's the third one that the males will have a higher standard deviation because this set of data is more spread out. I am so sorry that I sound so bad. Okay, let's keep going. In a small town in California, a real estate broker recorded the size of 10 houses in square feet and the selling price of each house. She plotted the data in the scatter plot shown below. Select the best description of the information in the scatter plot. There is a weak positive linear relationship between the size and the selling price for these houses. There is a strong positive linear relationship between the size and the selling price for these houses. There is a strong negative linear relationship between the size and the selling price for these houses. Or there does not appear to be any clear relationship between the size and the selling price for these houses. Let's see here. Looking at the data plot. Oh, oops. Um, if the sizes of the houses are increasing then the selling price increases. So it would be, I think, it would show a strong positive relationship, strong positive linear relationship. So I'm going to go with that because the pricing is increasing, the size and the selling. Yeah. A survey was taken in 2015 that asked people about the number of years of education they have completed and the number of children they have. The survey results are shown in the scatter plot. The correlation coefficient for this data is negative 0.439. Okay, so which of the following is true about these variables? Hmm. There is a perfect negative linear relationship between the number of children and years of education. There is a weak negative linear relationship between the number of children and the years of education. There is a weak positive linear relationship between the number of children and years of education. And there is no relationship between the number of children and years of education. Let's see. I think um hmm, I think because this is so, let me see here. Okay, so number of children, years of education, number of children. I think it's gonna be, I think for this one, it's weak negative linear relationship because it's like very scattered. There's a weak negative linear between the number of children and years of education. It's just like really scattered and not really showing like a correlation here. So, yeah, there's a weak negative linear, I believe. All right, question 11. Let's do a time check. Oh, gosh. Okay. A researcher used how many cigarettes in each state are sold per person to predict the number of deaths per 1,000 people due to bladder cancer. Did I read that right? A researcher used how many cigarettes? Okay. The least squares regression line she found is predicted rate of bladder cancer equals 0.673 plus 0.141 times cigarettes sold per person. Okay, so which of the following statements provides the best interpretation of the number 0.141 in the equation above? Let's see. Deaths per bladder pound is. Okay. For every additional 141 cigarettes sold per person, we predict 0.673 more deaths due to bladder cancer. Mm. For every additional 0.141 cigarettes sold per person, we predict 0.673 more deaths due to bladder cancer. For every additional cigarette sold per person, the predicted rate of bladder cancer increases by 0.141. And for every additional cigarette sold per person, the predicted rate of bladder cancer increases by 14.1. Let's see. I think I feel like the correct interpretation of that number is the 0.141 is, let me see. Since the regression line, let's see, slope. Uh, so the 0.141 indicates that for each additional cigarette sold per person, the predicted bladder cancer rate is going to increase. So I think that's going to be the for every additional cigarette the sold, the predicted rate of bladder cancer increases. That's what that stands for. For each additional cigarette sold per person is 0.141. Yeah. A statistics professor wanted to know if a student's score on the first test could be used to predict their final score in the course. He gathered data on his students over several semesters and calculated the following equation for the least squares regression line. He gathered data on his students over several semesters and calculated the following equation for the least squares regression line. Predicted final score equals 22 plus 0.73 times first test score. Okay. One student scored a 90 on the first test. Use the equation to predict the final course score for that student. Round your answer to the nearest whole number. So is it going to be 73, 88, 90, or 95? Um, okay, so the linear equation is the 22 plus 0.73 times the first test score. So you're going to do the substitute the 90. Okay, yeah, the first test score is 90. So you're going to put that in there and you're going to do the 22 plus the 0.73 times 90, which is going to be 87.8. And then that's going to round off to 88. A marine biologist, a scientist who studies animals that live in the water, created an equation for the least squares regression line to predict the weight of a salmon based on its length. The length The length of one particular fish was 20 inches, and the equation predicted a weight of 3.1 pounds. The prediction was not perfect. The residual for this fish was negative zero point 0.2. Which of the following statements is true? Okay. Is it the fish actually weighed 2.9 pounds? The fish actually weighed 3.1 pounds. The fish actually weighed 3.3 pounds. The fish was actually 19.8 inches long. Let's see. So the predicted weight is 3.1 pounds. The residual is negative zero point 0.2. Um, So the formula would be the actual weight is going to equal the predicted weight plus the residual. So the predicted weight 3.1 plus negative zero point 0.2 is going to equal 2.9 pounds. Okay. The scatter plot below shows the relationship between age and the number of motor fatalities in Texas in 2012. The least squares regression line is shown on the graph. This regression line has a coefficient of determination R square of 0.66. What does this value of R square indicate? The regression line accurately models 66% of the data. 34% of the variation in the number of motor vehicle fatalities can be explained by age. 66% of the variation in the number of motor vehicle fatalities can be explained by age. 66% of the data points indicate a correlation between number of motor vehicle fatalities and age. I think I think that this means that R2 um, equals the 66, which is the 66%. So that means 34% of the variation is due to the other factors. So 66% of the variation in the number of motor vehicle fatalities can be explained by age. Okay. Using the least squares regression line shown in the previous problem, what would be the predicted motor vehicle fatalities for 40-year-olds? So that was, I'm forgetting, 0.66. So I think it's gonna be, oh gosh, I don't know. I'm forgetting this one. Using the least square regression line shown in the what would be the predicted? Shoot. I'm gonna guess on that because I'm not sure how to do that one. Okay. Um, the value of a car generally decreases over time. This is called depreciation. For one particular brand of car, the depreciation closely follows the exponential model. Predicted value equals 22,500 times 0.85, where the age of the car is given in years. What does the 0.85 represent in this model? The predicted value of the car is decreasing by 85% per year. The predicted value of the car is decreasing by 15% per year. The predicted the predicted value of the car is increasing by 85% per year, and the predicted value of the car is increasing by 15% per year. Um, I think it is 0.85. I think it's decreasing. Decreasing, yeah, because of the depreciation. So it's going to decrease by 15% per year, the predicted value of the car. Yeah, decreasing, not increasing. All right. Cellular phone usage increased in the United States from 1985 to 2010. There were 340,213 cellular subscribers in the United States in 1985. By 2010, By 2010, the number of cellular subscribers in the US reached 300,520,098. The cellular is a big number. The cellular subscribers in the US in those years can be modeled by the equation. Predicted cellular subscribers in thousands equals 340 times 1.571. Based on this model, what is the predicted number of cellular phone subscribers in 1993? 4,273 or 12,725 or 4,273,073 or 12,615 and 33. Let's see here. I think it's gonna be 480, 4080. I think it's gonna be the 4 million number because you calculate the growth factor raised to the power of the number of years. So that is gonna be, yeah, close to a 4 million number here. When a disease outbreak begins, it spreads rapidly. An exponential model is often the best fit for the number of people with the disease after some period of time. AIDS death in the United States grew rapidly in 1990. The graph below shows exponential model. Use the graph to approximate the time that the number of AIDS deaths first exceeded 20,000, sorry. So let's see here. 1980, years from 1980. Ouch. So 20,000 is here. Exceeded 20,000 is going to be between 86, 1985, and 1986. Uh-oh. What number was I on? Oops, let me stop share. I will pick up where I left off because I did not have enough time to finish. Stop recording.